Good morning, everyone. Uh, Today we will discuss very interesting topic. Uh, the topic name is evaporation from the hydrology and water resource engineering, and myself are Suresh Kumar, assistant professor working in IARE, Dundigal, Hyderabad. So today we will discuss about what is meant by evaporation, what are the types of the measurement of the evaporation, and the applications and the uses can be discussed today's contents main. So here see what is meant by evaporation. As everybody knows, the evaporation is the changes of the from gas state from the liquid state to gas state is called evaporation. So evaporation is primarily that water moves from the liquid state into the water cycle as atmospheric water conditions. Next, it can be the oceans, seas, lakes, ponds, rivers like that. So these all are nearby 90% of the moisture in the atmosphere via evaporation only. So due to the remaining 10% being controlled by the plant transpiration, controlled by the transpiration. So during the evaporation, um, transpiration and will be the continued process of the transpiration, evaporation, and evapotranspiration, and some these are comes from the hydrological cycle we already discussed. Next, in the evaporation topic, the oceans accounts of the 80% of the water delivered from the precipitation, with the balance occurring on island waters and plant surfaces. Next one is factors affecting on the evaporation. What are the factors mainly affecting the due to the evaporation? The first one is temperature, and second one is surface area, and third one is atmospheric aqueous vapor pressure, and fourth one is atmospheric pressure on the liquid under the evaporation, and fourth one is type of the product required, and sixth one is economical factors. So these are the some of the factors which are factors affecting on the evaporation. And let us see one by one. So temperature, how the temperature will be affected in the evaporation process. In the evaporation process, everybody knows, of course, the temperature will be the most effective for the evaporation process. Let us see that one. The temperature rate of evaporation is directly proportional to the temperature. Of course, we know it very well. So temperature increases automatically, the evaporation will also be increases. So that is the main directly proportional to the evaporation and temperature relationship. The second one is surface area. How the surface area can be affected. So in the surface area, how it can be affected is the surface area is also directly proportional to the surface vessel exposed to the atmosphere. Here vessel means maybe ponds, maybe are rivers and lakes like that. All are comes under that one. The evaporation will be depends upon the surface area. If surface area is increases, automatically the evaporation is also increased. That's why we call it directly surface area is directly proportional to the evaporation. So next, the third one is atmospheric aqueous vapor pressure. So the rate of evaporation is directly inversely proportional to the atmospheric aqueous vapor pressure. So how it can be? So in the aqueous vapor pressure, the rate of evaporation is inversely proportional. Means the aqueous vapor pressure increases, automatically the evaporation will be decreases like that. So directly that's why the atmosphere aqueous pressure, how it can be clarified that in the atmospheric conditions there will be a lot of moisture content in the humidity like that. In the humidity areas, the automatically the evaporation will be the very less. Why? Because the evaporation, the moisture content in this atmospheric also there. So that's why this is also some of decreases the evaporation process. So in the water content or moisture content will be increases in the atmosphere, so the evaporation will be also be decreases. That is the atmospheric conditions of the uh, evaporation. Next, atmospheric pressure liquid under evaporation. So the rate of evaporation is inversely proportional as atmospheric pressure liquid under evaporation as. Next, type of the product required. A type of the product required means it means the selection of the method of the apparatus to be used in evaporation depends upon the type of the product is required. It means the evaporation different type of the water liquids like any of them. It depends on the liquid states and its conditions and evaporation conditions and the densities. I like that moisture content all or can be depends on the type of the products can be influenced. Next, sixth one is economical factors. So what is the economical factors can be affected? So when the selection method and apparatus, the economical factors are very important. So economical factors will be the method by evaporation losses will be calculated. Next, applications. So where the evaporation can be applicable in general. The first one is used for the preparation of liquid extract and soft extract and dry extract. These are the extraction of the some of the liquid and this evaporation process can be used. And the second one is in the concentration of the blood plasma and serum, and also it can be used for the evaporation techniques can. This and is also they also used for the manufacturing of the drugs containing the antibiotics carrying and enzymes, hormones, and many other substances are also used for the evaporation. Used for the purification of the vitamins. So these are all the scientific which are used in the evaporation. And here on the hydrology, water resource engineering, where evaporation will be the pan evaporations, and also some of the techniques and empirical formulas can be used. Let us discuss in the next content. Next, atmospherics can be used for the atmometers. So atmometers is the small devices can be used to measuring the rate of water in the evaporation from the wet surface to the atmosphere is called atmometers. So here there is a device can be direct measurement of the evaporation. Atmometers are mainly used farmers for growing up to measure the evapotranspiration rates occurs any of the field of the location. Here one thing we will discuss the later, but I will explain it. Evapotranspiration. Evapotranspiration is the combination of the evaporation as well as the transpiration. What is meant by transpiration? The extraction of the water evaporate from the liquid surface evaporate from the leaves and plants, which is the evaporator. We call it as transpiration. And the evaporation from the lakes, ponds above the ground level, the water can be evaporation due to temperature effect is called evaporation. And the transpiration, the both will be combined, evaporation and transpiration we call as evapotranspiration. Next, the rate of evaporation observed from the atmospheres on the higher side of the that any of the method can be used. Atmometer, see that one. This is the atmometer can be used low cost and can be easily to calculate the evapometers. The another one is pallet green can be used in the top and refilled and pot, and air entrance will be given in the side, and the side plastic tube can be used for the entering the water, and the back flow of the wall and the water level can be shown in that one. This is the inside the cross section of the atmometers. So design, how the atmometers can be designed. So in the atmometers can be consists of the wet process and ceramic cup and top as cylindrical water vapor pressure as explained in the previous one, which is cylindrical. The cap can be provided in the top, and also the reservoir is full with the distilled water that can evaporates out of the ceramic cup and is pulled down the suction tube and extends the bottom of the reservoir. Next, under underneath of the fabric which is already instructed in the top, in the ceramic cup is also provided by the special members membranes that keeps up the water, seeing the ceramic cup in the top will be inserted. Next to pitch atmometer. In the pitch atmometer is another one is devices to calculate the evaporation. Is consists of the graduated glass tube of 15 mm as it is showing in that one, and also it is 300 mm length. It is filled with water covered with filter paper, and also the tube will be inverted uh, so that there is a continuous supply of the water to the field of the paper. And again it one this loss of water from the glass tube is also due to the evaporation. This is simply the pitch atmometer. Next, advantages of this one. This is a low cost, easily to in operation, and also convenience to keep anywhere, and no computer or power required for this atmometers installation. What are the disadvantages for this one? In this disadvantages, and the bad weather can occur, the damage to the devices by due to the small devices, sensitive instrument can be damaged. Next, constant need of refill the water supply. Next, gas must be read manually, and you can we read the reading by using the not any electronic devices. We can be use it as manually. We can take the readings. That is the simply regarding the atmometers. Next, like pan operation is there. The estimation of the observation of the pan can be done. The actual evaporation from the correlated result of the reservoir. A pan. A pan is the metal container which is the square or circular, can be provided uniform cross section. Normally it can be provided circular, diameter ranges from 300 to 1500 mm. The pan is filled with water, and the loss of the water will be the pans can be specified period of the duration, can be on this pan can be used for the given the time is 300 1500 mm. So that is the rate of evaporation will be on certain duration of the time of 3 hours, 4 hours, 6 hours, 8 hours, whatever it is, the evaporation can be measured. Next to application of the uh, where the applications of the evaporation. Evaporation is the most important process of manufacturing pharmaceutical. It can use preparation of liquid extract, softenings, dry extract, and the concentration of blood plasma and serum, and already applications, purification of vitamins, and concern of course already concerned of the proteins can be also used for the different type of the uh, application can be used. And evaporation under the reduced pressure. In the reduced pressure of the evaporation increases advantage. Evaporation is occurs at low temperature with less risk of the damage to heat the sensitive materials. So the low operating temperature gives the high temperature gradient without need excessive streams of the pressure is the one of the major point of the under the reduced pressure. A low water operation temperature, lower steam pressure that can be used for the under the reduce the pressure. So up to this we have discussed about the atmometers, and the applications are already discussed. The main important thing, what are the methods can be used for measurement of or estimating the evaporation. So the first one is the can be used of the following using the evaporimeters. That is the first one, and using the empirical equations, and the third one is analytical method. So these are the three methods for estimation of the evaporation. So in this method, first one is using the evaporimeters, can be bifurcated, can be next types of evaporimeters. It can be used for which is exposed to atmosphere. The loss of water by evaporation from these pans are measured. Regular intervals of the meteorological data such as humidity, wind, velocity, and the temperature and precipitation also measured note along the evaporations. So the most important pans of the pan evaporation, there is the four types of the evaporation pans is there. The first one is US Weather Bureau Class A pan, and the second one is Colorado Sunken pan, and third one is
highest standard pan, and fourth one is US Geological Survey floating pan. These are the four type of the pan measurement for the very beginning of the first what we discussed about the evaporimeters. The pan coefficient can be four types. Very first one, US Bureau of the Class A pan. In the US Bureau of the Class A pan, let us see that one. In the Class A pan means it is a standard pan, can be used 1210 mm diameter and also 255 mm of the depth, can used by US Weather Bureau, can be known Class A land pan. US Bureau, United States Weather Bureau, and known as USWB in short form, can be known as Class A pan, can be invented. Next, the depth of the water maintained between the 18 centimeter to 20 centimeter. And next, the pan is normally made up of the unpainted galvanized iron sheet. Why unpainted? In the painted, there is can be protected the or absorb the heat, and the exact results cannot become. That's why it can be unpainted of the galvanized iron sheet, and the metal used due to the correlation in the problems. The pan is placed in the wooden platform of the 15 centimeters height and above the ground level. So, for calculation of this pan, the evaporation measures can be depth. The water hook gauge can be stilling of the well. Let us see in this one clearly. It can be known Class A evaporation pan. It the hook gauge is providing is the hook gauge. The levels can be known from this hook gauge, and this is the circular pan, galvanized iron pan, and the anemometers can be used in the side for calculation the evaporation, and the wooden board. Let us see another diagram. You can see in clarity the Class A evaporation pan measuring the evaporation, and hook can be provided in the top, and this is the unpainted galvanized iron pan. See, in a iron pan, the dimensions are very important. Is 1210 diameters and the 225 above the ground. Then 150 is the thickness of the wooden plate above that one, and 50 centimeters for the freeboard can be maintained. And why it can be above the wooden means to actual evaporation, it can be fixed in the above the ground level. Some of the heat can be absorbed to the ground in the bottom, so the evaporation exactly calculation will not be counted. So that's why we can keep the ground above the 150 of the wooden wooden plate. So wooden supporting will be inserted in the bottom of the pan. So this is also actually evaporation fan, can be protected by the mesh in the top, which is not the dust particles. Whenever it is the temperature effect here in the wind, any of the dust particles will not be enter into the fan. That is the generally we are providing the Class A evaporation fan in general. So that they see that one the evidence plane clearly given the 15 mm, and above the pan will be inserted with some protection will be there. That is the actual diagram of the evaporation. Next, second one is Colorado sunken pan. Colorado sunken pan. In the Colorado sunken pan is provided another second one 920 square pan are made up of the unpainted J sheet, and in the previous one the circular one they are going to be providing. Here see that one unpainted GA sheet of the over 60 deep and buried into the ground 100 of the top can be maintained. So let us see that one. You can understand it easily. And here see the Colorado sunken pan 920 square of that one in the bottom can be providing, and the top will be the 460 in the from the bottom to above the top, and freeboard of 50 can be maintained the constant above the ground level. The water level maintained at the ground level. So this is the simply the providing the Colorado sunken pan. In the Colorado sunken pan, let us see the back. So Well, you are going to be providing inside the ground means this is also some of the effects in the ground. So the ground inside, in the insert of the ground level, what happens? Some of the observation of the heat or some of the cooling effect can be in the sides and the bottom. At the situation, actual situation, the evaporation, how it can be affected, can be seen and also measured from this Colorado sunken pan. And next one is in the ISI standard pan. IS standard pan is nothing but the specified IS standard pan is a 5973 Indian standard known as modified class of the pan A. The pan A is providing the modified. Some of the modification will be given here. A pan diameter is this is the different from the previous one. 120 mm diameter and the depth will be the 250 mm can be maintained. The pan is made up of the copper and 0.9 mm thick and trained inside the painted white outside. The pan is placed on the square wooden frame of the width 1225 mm and the height of the 100 mm can be. These are the dimensions is very important for the each of the evaporation of the pan. So the, above the ground level, they allow the fair circulation below the pan. Next, this is the simply diagram which I collected from the textbook. So here ISI standard pan is equal to there is a 1220 mm as in previously explained, and the 100 mm in the wooden plate can be providing in the bottom side, and also there is some of the levels which are providing, and the stilling well for the water calculation, and the fixed point gauge is provided here. This is some of the fixed gauge here, and also a copper sheet inside the thickness of 0.2 mm can be what is the pan thickness. So that is the wire mesh can be provided as shown in the top for protecting the insects, whatever it is. Some of the atmospheric dust particles and waste particles cannot be entered into the pan, can be disturbing the evaporation. That's why we can provide it on the wire mesh in the top. In the top we are providing. So this is the simply of the and Indian standard IS standard pan. Next, a fixed point indicator. What is the indicator of that one? Level to maintain, and water is added or removed from the pan to maintain the water level. Fixed mark to the calibrated cylindrical measure. Cylindrical measure can be used. Next one is point is the top one of the pan is covered with hexagonal wire, as I explained. GI of the protected water from the pan's birds, insects, whatever it is, can be dust particles can be reduced. Next, the presence of the wire mesh is the temperature of the water to uniform the day and night and can be maintained. Next, the evaporation from this pan is about 14% of the lower as compared to the unscreened pan, can be lower of the. So for this this one, evaporation from this pan is 14% lower as compared to that of from the unscreen of the pan. So this is the simply IS pan. Next, the next one is USGS floating pan. So USGS United States Geological Survey can be floating pan. So in the floating pan, a square pan of also 900 mm sides and 450 mm deep, supported by the drums of floating and middle raft of the size 4.2 meters divided by 4.87. This is the dimensions which is given, and it is set afloat lake view of the simulate characteristics of the large body of the water. Next, the water level is maintained in the same level and leaving the rim of 75 mm. So these are the dimensions are given, and diagonal buffets are also providing in the pan to reduce the surroundings of the pan due to the wave action. So reduce the wave action can be provided. Let us see the see that one. This is the US Geological Survey floating pan. Can be sides can be providing like that to reduce the waves in the sides effect. in the all these sides the waves can be protected from this one. So this is the US uh, geological survey plan. Actually, what we saw, this one is the correct in the lake, in the lakes and ponds, how it can be effectiveness of the evaporation will be known from this experiment. I think so. In the how the in the previous one we are estimating the outside only, but in the estimation the actual evaporation can be lakes and ponds, whatever it is, the water storage in the areas, how the affected in the evaporation will be known by US Geological Survey floating pan. So this is the fourth one, very important one. So how the evaporation can be affected. So I'll see that one disadvantages of this one: high cost of the installation and the maintenance of the difficulty to making the measurements means the inside of the ponds and lakes can be, you can go and without disturbing them you calculate the maintenance and take the readings is some difficult task. Uh, so that's why this is a small disadvantage for the USGS pans, floating pan. Next, pan coefficient, the very important small, but this is the pan coefficient. What is meant by pan coefficient? In the observation of the pan extracted from the reservoir using the pan coefficient. So in the pan coefficient means whatever we are taking the small areas can be consideration as the evaporation, but in the small area and what are the given the catchment areas and the big areas can, how it can be implemented can be known in the inside the ground or outside the ground or inside the water. So these are all can be affected in the pan coefficient is the best solution for this one. So in the pan coefficient may be modified as in the rate of evaporation from the reservoir, rate of evaporation from the pan lake evaporation is equal to pan coefficient into pan evaporation. So actually we want the pan coefficient is equal to lake evaporation divided by pan evaporation. This is the formula to calculate the exact, the small one to a total area can be influenced, will be known for this pan coefficient value. So the pan coefficient will be varies from the always less than 0, 1, less than 1, because in the pan is very small area that I explained, exposed to the atmosphere, and secondly the metal container absorb more energy from the total utilization of the evaporation. Next, it is a dimensionless can be taken. Let us see the pan coefficient value will be the different type of the pans, how the lake evaporation is equal to pan coefficient to pan evaporation. The pan coefficient value is equal to ranges. See the pan A is equal to class A land pan is equal to 0.7 and the ranges from 0.6 to 6 to 0.8, and second one ISA pan modified is equal to 0.8 to 0.65 to 1.10. This is the second one, and the third one is sunken pan is equal to 0.782 and 0.75 to 0.86, and USCS floating pan is equal to 0.80 to 0.70 to 0.80. These are the ranges of the pan coefficient values from the all the what we are discussed about the four type of the pans. The next, any drawbacks of the evaporation pans? Yes, the heat transfer of the characteristics of the pan metal are different from that of the reservoir. Next, the why? Because as I told, the small characteristics transfer of the whole area of the can be affected by metal different from the reservoir. Why? Because the pan, the heat transfer and heat observation content is different, and the outside the whatever we are storing of the water of the conditions are different. So hence evaporation measures from the pans has been corrected and get evaporated from the large lake under the identical climatic and exposure conditions. Next, evaporation stations, where we have to provide the evaporation stations. Generally, as per specification guidelines are given, World Meteorological Organization will be recommended some of the following values of the minimum density evaporation will be first one is arid zones. In the arid zones, the one station for every 30,000 kilometers we are providing the evaporation stations, and humid temperature zones. If it is humid temperature zones, the station will for every 50,000 square kilometers can be we have to provided the evaporation stations. In it is cold regions, just like western countries, the station for every 1 lakh square kilometers can be we have to be provided. These are the exactly giving the specifications or guidelines are giving the providing the evaporation station can be taking the values. So at it, so a typical for recording rain gauge, wind atmometers, wind fan evapometers, sunshine evapometers. These are some of the givens in the hydrometeorology stations are the following gauges. And so in this part, we have to finish it here regarding the fan evapometers, and remaining will the two type of evaporations like that, the empirical equations, and also some of the what I told, this one analytical methods. So the evapometers is evaporation from the pans is already over, and using the empirical equations and analytical methods can be discussed in the next of sections. I will finish here today. So this is the briefly about the evaporation pans by measurement of the evaporation of the by using the different type of the pans. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.